Let us do a simulation for the half bridge converter circuit. I have here in this folder within the resources half bridge folder, which is containing the subcircuit files, the models, the half bridge schematic, and the CIR file in the netlist. So let us go to the schematic. This is the schematic of the half bridge circuit. I have the DC link set up by these two capacitors, equal capacitors, 100 microfarad and 100 microfarad capacitors. I have balancing resistors there across this, and this forms the DC link with the center point being VDC by 2. Now on the other side here I have two switches, a bridge arm with two switches, Q1 and Q2, or SW1 and SW2. Now these two are generic switches driven by two gate drives G1 and G3, and G1 and G3 are coming from the PWM block, which I explained while doing the push-pull circuit. Similar same block which is generating 4 signals, and if it is for full bridge I use all the 4. Otherwise you can use the top one top, or G1, and you can use the G3 2 top. These two, 1 top and 2 top, must be mutually exclusive. 1 bottom and 2 bottom must be mutually exclusive. Either you can use G1 and G3 or G2 and G4 for these two switches. So I am using G1 and G3, and in between you have this full bridge, you have this bridge transformer, the same type of transformer for both the full bridge and the half bridge. I am using a sensing voltage source here with 0 volts, and this will sense the current through the primary. And the secondary of this bridge is center tapped. The dot end is going through D1 diode, the non-dot end through D2 diode. They are ORing up at the pole point, and then you have the inductor followed by capacitance and the load. R is the reference node on the secondary side. So anything that you want to measure on the secondary side, whether it be the output voltage or the pole voltage, you measure it with respect to the reference node R. So now we can simulate this circuit and see how it behaves. I have now opened the terminal. I am within that resources half bridge circuit, half bridge folder, and let me generate the netlist first. So the netlist is generated from the schematics file. So you can generate the netlist and then you simulate the circuit. ngSpice halfbridge.cir. Yeah, before we simulate CIR, let us have a look at what is within this halfbridge.cir. See, halfbridge.cir contains this one. You have the simulation commands .option .tran, which is the analysis command, include halfbridge.net, and then in the control set of commands in the ngSpice environment, setting the background to white, foreground to black, running the simulation and plotting IL inductor current, the diode D1 current, and the primary current. These three proper currents we will see. So let us go back and do the simulation now in the terminal. So I will do the simulation. Simulation is performed, and then you see all this waveforms coming up. Let me go to the steady state and you will get an idea of what we are seeing. Yes. So here you see the red waveform is the inductor current, and the blue waveform is the diode D1 current, just like in the push-pull case, and the orange waveform is the primary current. Probably we can zoom in a bit and see. You will get a much better view. Few cycles. Yes. Now this gives you a much clearer picture. So you see the primary current 1, 2, 3, 4. 1, 2, 3, 4. It is an AC current flowing through the primary that is the AC current flowing through the primary. So you see that when the switch S1 SW1 is on, you have the current flow in this fashion into the dot, and when the switch S2 is on, you have the current flow into the non-dot end, coming out of the dot and into the ground. So you have current flow on both directions, and it is basically a reflected inductor current onto the primary. Here too, in the bridge transformer, I have set primary turns as 10, secondary turns as 20. You can explore with other turns ratios. And the sub-circuit for this bridge transformer, you will find it in edt01.sub. If you open edt01.sub, the sub-circuit model for the bridge transformer is here. See, it also uses the gyrator sub-circuits, and the gyrator is modeled just above that. There is a gyrator here. As I told you, the modeling of these transformers, we have used analog behavioral modeling, and you can study that separately. And I am using the same PWM bridge PWM generator, and we can go back to the schematic, and this is what it is. So I will now leave it to you to change and explore the various waveforms of the half bridge circuit. You can try to see the pole voltage and the output voltage too. Maybe I can show that to you briefly before closing. Plot V pole voltage with respect to the reference node R. Plot output with reference with respect to the reference node R. See the outputs, and when you expand it, you will be able to see both the pole voltage and the output voltage. Here is the pole voltage, and the blue one is the output voltage here. So you can calculate what is the expected output voltage. Of course, here you should remember that what appears across the primary of the half bridge transformer is VDC by 2, and that gets multiplied by the turns ratio and then into the duty cycle, 2 times the duty cycle of the switches. So you will see that it will the duty cycle, we have set it at around 25%, 2 times the duty cycle 50%, and VDC by 2 coming into the picture, and therefore you will see the output accordingly here. Observe that I have set NP as 10 turns, NS as 20 turns, and this NS implies overall NS, so it is actually 10 turns here and 10 turns here. The turns ratio between this one to the center tap is 1 then. So you have 10 volts coming in here as 5 volts, and N times 5 volts, and into the duty cycle 2 times D to 0.5. So you will see that the expected output will be 5 volts, but it will be slightly lesser because of the diode drops and the saturation drops occurring in series. So accounting for all that, you will see less than 5 volts, and that is what we are also seeing somewhere around 3.5 volts. And the pole voltage instead is coming at around 7.5 volts.